Okay, students, can you hear me? Can you hear me? All right. Yeah, good evening to you. Good evening to all of you. Right. So good evening for all of you. So today we have to discuss from the question number 4 in the 2016 Vishaka Vidyalaya paper, right? So last week we couldn't discuss the paper. So today we have to start from question number 4. Yes. So we were discussing 2016 Vishaka Vidyalaya paper. Right. Let's move for the question number 4. Part A, problem number 1. Define the Avogadro constant. Right. So what is Avogadro constant? We have to define that one. We can tell that Avogadro constant means the number of particles. The number of particles. Particles means, students, we can tell more number of electrons, number of ions, number of molecules. Likewise, any kind of particles that we can consider, right? The number of particles in 1 mole, right? So this is the highlighted thing. 1 mole is considered as Avogadro constant. Avogadro constant value is considered as 6.022 10 to the power 23 per mole. So that is the unit. So we use the symbol L or else in subscript A. Okay. So this is the Avogadro number. Sorry. So the next one is a calculation. So let's see what is it. The volume of 17.7 milligrams of organic solvent at 27 degrees Celsius is 0.472 cubic decimeter. The volume of a molecule is 8 into 10 to the power minus 18 cubic centimeter. Calculate the molar mass of capital A, right? So what they have given? The volume of 17.7 milligrams of organic solvent at 27 7 degrees Celsius is 0.472 cubic decimeter, right? Right. So we have alternative answer for the Avogadro constant. Let's see. So can't we write the number of carbon 612 atoms exactly weighed? 12 grams of carbon 612 isotope. This is given in resource book. Yeah, that is also correct. That is also correct. That means if you consider a 12 grams of carbon 612 isotopes, the number of carbon 612 atoms in that sample is considered as Avogadro constant, which is 6.022 10 to the power 23, right? So that is also correct. But this is the easier definition, right? The number of particles in 1 mole, right? So you can use any kind of definition using the carbon atoms also, you can find it. So Shala, you are a newcomer. I don't have the questions. Okay. Doesn't matter. I will send you the soft copy to the group again. So you have to ask from that me, okay? Understood. So where are the questions? Can you send it? Because you have to ask. I'll send it again. Wait. So where is the PDF? PDF. Got it. Okay, Shala, now check the WhatsApp group. I have uploaded the PDF. So manage with the PDF quickly. Right. Actually, now we are about to end the paper book. I think today, yes, probably we can end this one, if not next week. And in the following week, you will have another new tutorial, the paper book 4, right? Right. So let's move for the question again. The volume of organic solvent. We have organic solvent. Which is 17.7 milligrams, and the volume of it is given 0.472 cubic decimeter. The volume of a molecule is, right? If you consider just one molecule, so the volume of it is 8 into 10 to the power minus 18 cubic centimeter, right? So volume of a molecule is equal to 8 into 10 to the power minus 18 cubic centimeter. Calculate the molar mass, right? So we need to calculate the molar mass of that solvent, right? Okay, students. Now look at this one, will you? First of all, you know what does mean by the molar mass. Molar mass means capital M equal simple N divided by the mass. Grams, simple M divided by simple N. Grams per mole. So that is the unit. Mass divided by its number of moles. So that is considered as its molar mass, right? So they have given the mass of the organic solvent, that is 7.7 milligrams. And they have given the complete volume, total volume is given. And they have given additionally volume of a molecule. That means how many, what is the volume for one molecule? This is the total volume. Then what you can find out from these two parameters, right? They have given the total volume of the organic solvent, right? and here we have volume of a molecule. Then what you can find out here? We can find out the, yes, number of molecules. How many molecules are there, right? Therefore, let me find out the number of molecules. Number of molecules equal to, so this is a simple calculation. The total volume, look at the total volume, 0.472 cubic centimeter. How about if I convert this one into cubic centimeter? Then that will be easy, right? We know that 1 cubic decimeter is equal to 1000 cubic centimeter. So therefore, in order to convert this one into cubic centimeter, you have to multiply this one by 1000. Then 472 cubic centimeter. Then total volume is divided by the volume of one molecule. 8 into 10 to the power minus 18 cubic centimeter. Then you can get the answer. Check whether 472 is divisible by 8 or not. Anyway, we have to divide that one. 472 divided by 8. So here we have 5, 40, 72, 9. So it is nicely divisible. 59 into 10 to the power 18 molecules are there. Right? If not, I can tell that 5.9, 10 to the power 19 molecules are there. 5.9, 10 to the power 19 particles are there. Right? So in order to find out the molar mass, what do we need exactly? We need two parameters. Mass of the solvent and the number of moles. But here we have number of particles, number of molecules. Just now we discussed about the Avogadro constant. Avogadro constant means the number of particles in 1 mole, which is 6.022 10 to the power 23. Now, when you go for this organic solvent, look at this one. We are talking about this organic solvent. In this organic solvent, right, we know that 6.022 10 to the power 23 particles are representing 1 moles. Then we have this much of particles, 5.9 10 to the power minus 19. Then how much of moles are there? Right? Very easy. By dividing the total volume from one volume of one molecule, we found the number of molecules, number of particles inside the sample. And we know the connection Avogadro constant is equal to 1 mole. If I take 1 mole of anything, there are Avogadro number of particles. Or we can go for the reverse, vice versa. If there are Avogadro number of particles, there is 1 mole. Then if we have 5.9 10 to the power 19 molecules, how many moles are there? That means we can find out the number of moles of Avogadro organic solvent, right? Now look at this one. Simple mathematical connection. Then number of moles will be 6.022 10 to the power 23. Molecules are representing just 1 mole. Then 5.9 into 10 to the power 90 is representing how many moles? Right. Now we have 5.9 divided by 6.022 10 to the power minus 4 moles. Am I correct? I know that if I apply the log values here, since the numerator is lesser than the denominator, I will have a negative logarithms. So in order to avoid the negative logarithms, let me make this one as a positive value, a larger value than denominator. And then here we will have 10 to the power minus 5 moles, right? And now do the simplifications, right? So where is the logbook? Don't be lazy to do the logarithms. Logarithms are very important. Log value for 59, 1.590 is 7709. And here Avogadro number 62.2. What is the log value? 7797. Now take the difference. 2 here, 0, 8 means 6 means 9, and here also 6. 9, 0. Check whether the value is correct. 9. Oh, here should be 1. Eh? Yes. 9912. Check the antilog. 9912 antilog. 9912. 9912 is 980. That means we have 9.8, 10 to the power minus 5 moles. So these are the number of moles of that organic solvent. Right? So check whether can you understand what I have done up to here. Is everything okay? Do you have any doubts? If you have any doubts, put your doubts in the chat box quickly. So these things are very easy. Then you can apply this one for the equation. What is the mass, students? What is the mass that they have given? 17.7 milligrams. Milli means we know that is 10 to the power minus 3 grams. And how many moles are there? Just now we calculated, that is 9.8, 10 to the power minus 5 moles. Right. Okay. Now do the simplifications and find the answers. Sorry. 17.7, is it divisible by 98? No. Then what we can do? We know that log value for the 98 is 0.9912. What is the log value for 17.7? 1.2480. So 8 here, 6, 5, 1 means 2, 0, right? 2568 antilog. 2568 antilog. 18, 0. 68 means 13. 15. 15 means 1806. 1.806. 10 to the power minus 3, here minus 3, minus 2. So therefore, this is plus 2 grams per mole. Then the answer will be molar mass of the compound will be 180.6 grams per mole. Approximately, we can tell this is 180 grams per mole. So this is the answer for the molar mass of the compound. Right. So if you have any doubts, tell me. Yeah. Can anyone guess what is the compound approximately? If the value is 180, what can be the molecule? That is actually well-known molecule. Yes, very good. Very good, very good, very good. Yes, good. No? Glucose, C6H12O6, that is glucose. So they haven't asked that kind of a thing, but they have asked only the molar mass of that compound, right? If you have any doubts, quickly put your doubts in the chat box. Let's discuss. These are very easy calculations. Right. Question number 4, simple B. Question number 4, simple B. Nitric oxide is a toxic gas which is emitted to the environment in vehicle emission. Release of nitric oxide can be avoided technically by reacting nitric oxide with ammonia gas as follows. They have given the reaction also. by the reaction between ammonia and nitric oxide, it is producing nitrogen gas and water. A vehicle emits 5 grams of nitric oxide when traveling a distance of 1 kilometer. This vehicle travels 12,000 kilometers per year. Calculate the number of, not male, a number of moles, right? Typing errors. Right. So first of all, let me write down the reaction here, because this reaction is important in order to do the calculations in the upcoming questions. Ammonia gas is reacting with 6 nitric oxide to produce nitrogen gas into gas 5 into plus 6H2O. Right? So this is the way. Now we can see that in the first question they have asked, calculate the number of nitric oxide moles. They have given the mass of nitric oxide. So the mass of nitric oxide they have given 5 grams. Then what is the molar mass? Molar mass is equal to nitrogen 14, oxygen 16. So the summation is equal to 30 grams per mole. In the essay paper, you have to do these calculations and show up. That's the way. Then number of moles of nitric oxide will be 5 grams divided by 30 grams per mole. Grams will cancel off. And here 1 over 6 moles. Right? So 1 over 6, if you simplify that one, answer will be 0. 10 means 1. 40. That is repeating. We can write down 0.167 moles. So these are the nitric oxide moles. Okay, that's very easy. Right. And the next one. Calculate the mass of ammonia reacts with NO mentioned in part 1. Right. Look at this one, students. Now, what is the reaction between ammonia and nitric oxide? Ammonia and nitric oxide, the reaction stoichiometric ratio between ammonia and nitric oxide is 4:6. That means 2:3. 2 moles of ammonia reacting with 3 moles of nitric oxide. Then we can find out the ammonia moles. If 3 moles of nitric oxides are reacting with 2 mole, with 1 over 6, how much the moles are reacting? Got it? According to the reaction stoichiometry, we know that with 3 moles of nitric oxide, 2 ammonia moles are reacting. Then with 1 over 6 nitric oxide moles, how much of ammonia reacting? So this is simplifying 1 over 9. So since they are asking the mass, I'm not going to simplify this one. Let me find out the molar mass of ammonia. Nitrogen 14, hydrogen 1. So 1 into 3 grams per mole. So what is the answer? 17 grams per mole. Now you can find out the mass of ammonia. How is it? 1 over 9 moles multiplied by 17 grams per mole. Per moles will cancel off. Then the answer is 17 divided by 9. So when you divide 17 by 9, we have 180. 480 how much? 7. No, 8. So that is repeating. We can tell that answer is 1.89 grams is the answer. So they have not clearly mentioned we must calculate for 1 kilometer, right? If I take the mass of nitrogen oxide for 12,000, will that be correct? Yes. Yes, 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 yes. Right. Students, they have given finally. Yes, there is a issue in the question also, but it's okay. Doesn't matter. Look at this one. Finally, they have given the vehicle travels 12,000 kilometers per year. Actually, in those questions, they have asked about how much of moles of nitric oxide per year. Because if not, they should not have given this statement. So therefore, let's calculate. So the same number of moles, let's multiply it by 12,000. This is for 1 kilometer. We know that 1 grams of nitric oxide is emitted for 1 kilometer. Then for 12,000, how much? So what you have to do? You have to multiply this one for 12,000. That's all. I think the answers will be nice if we use 12,000. Yeah. If I calculate the nitric oxide molecules per year, 1/6 multiplied by 12,000. Then the answer is 1, 2. So 2,000 moles. Let's calculate that one for per year. Okay. Per year, right? So these are the nitric oxide moles per 1 kilometer. So this is for 12,000 kilometers, or else we can tell that per year. Then here also in the same way, we can say that what is the mass of ammonia react with NO mentioned in the part number 1, right? So look at this one. We have to repeat this one again. Doesn't matter. Per 1 year, we know that there are 2,000 moles of nitric oxide. As I mentioned you, the reaction stoichiometry between ammonia and nitric oxide is 2:3. That means 3 ammonia molecules are reacting with 3 nitric oxide molecules are producing 2 ammonia. 3 nitric oxide molecules are reacting with 2 ammonia. Then 20,000 are reacting with how much moles? 4,000 divided by 3 moles. And we calculated that molar mass of ammonia is 17 grams per mole. Then we can find out the mass of 4,000 divided by 3 moles multiplied by 17 grams per mole. Now do the simplification. When you multiply 17 by 4, answer is 868, right? And this 68 should be divided by 3. Then the answer is, we can say, tell that 2 here and here also 2. 66. For 20 we have, so that is repeating. Then we can tell that 22.67 10 to the power 3 grams. That means 22.67 kilograms. Now, okay, this is the way. Right. So try to understand in that question they have given finally. This is the nitric oxide emitted from the vehicles per 1 kilometer. Right. So that means per year traveling 12,000 kilometers, then you have to multiply that one by 12,000. Then you will obtain the nitric oxide molecules. And then in order to obtain the ammonia which is reacted with that one, use the stoichiometry ratio. Then find out the number of moles of ammonia reacted with. And then multiply that one by the molar mass. Yeah, 1.89 multiplied by 12,000. Is it giving the same value? Check whether. Then okay, right. Yes. That means per 1 kilometer, we are obtaining 1.89. Then in order to find out that one for 12,000, yes, still give the same value. Yes, that is correct. We can do in that way also. We have to read the question very carefully when we are doing the calculation questions. Right, next one. Draw the bond type present in N2 molecule. They're asking to draw that one. Yeah, it's not a big deal. Why? Look at this one. N2 molecule. What is it? They're asking to draw the bond type. Okay. So they are expecting the Lewis structure. And we know that this bond is actually non-polar covalent. Okay. If you want to go further, you can mention that this is a sigma bond and these are pi bonds. Right? Quickly. If I draw the orbital diagram, it's look like this. This is the sigma bond, right? And these are the pi bonds. And this is the interaction between the pi bonds. Linear overlapping and the lateral overlapping. You can see that here we have a linear overlapping and these are lateral overlapping. These two electron clouds are mixing, right? So here also we have electron cloud and here also we have electron cloud in the orbital. So they are laterally overlapping and they are mixing and forming a bond, which is a very weak bond. And here we have other kind of a pi bond, right? Try to understand. When they ask to draw the bond type, whatever it is doesn't matter. You just draw the Lewis structure and mention non-polar covalent bond. That is also enough. If you want to draw the orbital diagram, that is also enough. Here I have represented everything, sigma, pi, and everything also I have mentioned, right? So if I am writing for that question, I'm writing answer for that question, I will write down everything, right? Because we don't know in the mark scheme what they are really expecting. Okay. So you write down everything. Draw the Lewis structure also, draw the orbital diagram also. Bond type means actually we cannot exactly tell the Lewis structure. So there is an issue like that. So therefore, better we mention these things also. Neither. We have to prepare for everything. Then they're asking draw the dot and cross structure. This is not the Lewis dot dash structure. They're asking an dot and cross structure. How we can draw that one? First of all, let's draw the Lewis structure for NO molecule. So this is the NO molecule. We have discussed about NO molecule. What is the specialty of that one? Electron deficient compound. In this way, there is an unpaired electron in the nitrogen atom. So therefore, since they are asking the dot cross structure, we can write down in this way. Let's assume that the cross belongs to oxygen. In this way, okay. But remember, in the examination, they won't ask these kind of easy questions. Right? Shall we move for the next one? Question number 4, part C. So can we draw the dot and cross one after the other in the bonded pairs? Dot and cross one after the other. I didn't understand. What is it? Dot cross in one line. Don't do that one. Don't draw the dot cross in the same line, because we have to represent there are two bonds. So therefore, better you follow the two cross. Understood? If there are three bonds, put them in three bonds. Don't put them into the same line. That is wrong. It's not the standard way of drawing that one. Right? Part C, Rome number 1. Define empirical formula and molecular formula. You very easy. What is the empirical formula and what is the molecular formula? We know that empirical formula means the simple mole ratio between the elements in a compound, right? Empirical formula, the simplest integer ratio between the elements in a compound. Then, what is molecular formula? Molecular formula means the exact ratio between the elements in a compound. Right? Next one. Rome number 2. No, same Rome number. Molecular formula. Molecular formula. The exact integer ratio of the element in a compound. Right. Next one. Rome number 2. Compound capital X contains 29.1% of sodium, 40.5% of sulfur by mass, and the rest is oxygen. The molecular mass X is 180. Find the molecular formula X. Right. In a compound, we have sodium, sulfur, and oxygen. So there we have to find out the empirical formula and the molecular formula. They have given the bottom as well. Right, students. Now you have learned chemistry for 1 year, right? From the knowledge that you gain, can you guess the compound? Anyone here? Very good, Asma. What about the others? Opeshani, Lashmi. How the other session again? Let's see. Lashmi, Nimeshi, Akash, Asdi, Asma, Bush, Zainab, Imani, Ritaj, Mariam, Manugi, Opeshani, Sachin, Rafa, Sehanti, Sinetma, Senitu, Shahala, Shaima, Faumi, and Supipi. Right, guess the compound. Let me see your guesses. Guessing. Yeah, Sachin, correct. Akash, okay, good, very good. Rafa, correct. Mariam, yes, correct, very good. Yes. Actually, I suspect about what? Sodium thiosulfate. But let's see, yeah, whether it is sodium thiosulfate or sodium sulfite to sodium sulfate, we don't. Let's see. Right. Now look at this one. So we have the ratio sodium, sulfur, oxygen. These are the elements that we have. So sodium 29.1, sulfur 40.5, and the rest is oxygen. So when you take the summation of these two, 29.1, 40.5, summation is equal to 6, 9, 69.6. And then here 4, 0, 3. Then yes, then the oxygen is 30.4. Right? So this is the mass ratio. Then how you convert this one into moles? You have to divide this one by its molar mass, 23, sulfur is 32, and oxygen is 60 in this way. Right? Now find out the values. Find the values. We know that 29.1 logarithm, 29.1, 4639, and what is the log value for 23? 3617. Take the difference. 2201. Yes, 0.1022. Antilog 1022. 1022, 12, 6. We have 18. 1265. 1.265. Log value for 14.5. 1.45. 6075. And 32, 1.5051. Take the difference. 4201, 0.1024. 1024 also, I think same, almost same. We took that 12, 6. Now here we have 20. That is also 6.5. According to the log table, same value. Right? That's easy for us. Let's see. And then here we have 30.4 divided by 16. 30.4 means 4829, and 16 2041. Take the difference. 8. Here also 8, 7, 2. Sorry. Antilog of 2788 or 90. 1.9. Right. Okay, right. So this is the mole ratio. In order to obtain the simplest mole ratio, I'm going to divide this one by the smallest value. So this is the smallest value that we can obtain. Then here we have the answer 1, 1. 1.9 divided by 1.659. 1.265. Then the answer is 0. Log value for 1.265 is 1265 now. 1265, 21. Now take the difference. 7, 6 here, 7, 1. 0.1767 antilog. 1502. Right. When we are doing the empirical formula, molecular formula calculations, I taught you what you have to do in this kind of a situation. Right? We know that here 1.5 we can't approximate this one into a 2 or 1, right? So therefore, in this kind of a situation, what you have to do? You have to multiply this one by 2, ne? Yes. You are going to multiply the whole ratio by 2. Multiplied by 2, multiplied by 2, multiplied by 2. Then you are having the answer. Sodium, sulfur, and oxygen ratio. You will be having the answer as 2 is to 2 is to 3. So the empirical formula of the compound is equal to Na2S2O3. So this is exactly equal to the molecular formula of sodium thiosulfate, Na2S2O3. I think here empirical formula, molecular formula, both are same. But anyway, since they have given that the molecular mass is 160, let's find out the correct value, correct molecular formula. We know the connection between the empirical formula and the molecular formula. Molecular formula equal empirical formula in times. Empirical formula n times. Then n equal molecular formula mass divided by the empirical formula mass. Molecular formula mass, they have given 160. And what is the empirical formula that we obtain? Na2S2O3. Sodium 23 into 2, 46. Sulfur 32 into 2, 64. Oxygen 16 into 3, 14. Take the summation. 10, 18, 1, 5, 9, 9, 6, 158. Yeah, almost equal, right? Approximately, we can tell that n is equal to 1. It is 1 point something, but approximately we can tell that is 1. That means empirical formula, molecular formula, both are same. So molecular formula of the compound is also same as empirical formula Na2S2O3. Right? If you are given this question to do that one in essay paper, this is the way, steps so that you have to follow. Right? Okay. If you have any doubts, tell me, right? Put your doubts in the chat box. Wait. Sorry. Right? So this is the last question in the Visakha Vidyalaya paper. Question number 4, part C. Let's see. Right. Problem number 3, they're asking about the hydrated salt of this compound. A question related to the hydrated salt of this compound. Let's see what is it. Sorry. Problem number 3. So we have a compound X into NH2O. We know that X is Na2S2O3 and NH2O. So this is the compound. They are heating 12.4 gram of sample of this compound, and we know that by heating this is forming Na2S2O3, and H2O is released as gas, right? NH2O. So what is the mass of H2O? 4.5. And they're asking us to find out the value of N. So how do you find out that value? So let me take the ratio between again sodium thiosulfate and H2O. Right? Mass H2O 4.5 grams. So this was the total mass 12.4, 4.5. If you subtract that one, you will get the exact sodium thiosulfate mass remaining in the compound 9 and 11, 7.9. Understood? So this is 7.9 grams. So if you convert this one into mole, you will get the ratio. By looking at the ratio, you can easily tell that one. So what is the molar mass of sodium thiosulfate that we calculated previously? 158 grams per mole. What is the molar mass of water? 18 grams per mole. Grams will cancel up here in this way, right? And we know that this is actually 7.9 divided by 158, and this is 4.5. So here you will have the answer. 79 is 158 is twice of 79. So therefore 1 here to 0.5, 0.05. And here 45, 58, 18. If you divide that one, 2 here, 5. So therefore 2.5, 0.25 moles, right? If you take this one as a ratio, what should be? I'm going to divide this one by 0.05, 1. If we divide this one by 0.05, so therefore we can get the answer 1:5 ratio. That means 1 sodium thiosulfate is connected to 5 water molecules, right? Then 1 sodium thiosulfate is connected to 5 water molecules. N value is equal to 5. Easy. Can you understand? These are very easy calculations. You have to practice these things. Okay, quickly complete this one. Right. Let's move for the next question. Explain briefly how you prepare 250 cubic centimeter of 0.5 moles per cubic decimeter solution using anhydrous salt of X at the laboratory. So we have discussed these kind of questions in the theories also, right? Very easy. Let's see. That's very easy. We need to prepare a solution, sodium thiosulfate aqueous solution. According to the stoichiometry, if we put one H2O molecule, it is also balanced. Yeah, one H2O is balanced, but we know that the given masses are not balancing. According to the given masses, Akash, the ratio between sodium thiosulfate and H2O is 1:5. So therefore, 1:1 is not appropriate answer for this one, right? So according to the masses they have given, 1:1 is not the mole ratio. So therefore, according to the masses, we have to put there 1:5. Okay. We have a solution. We have to prepare a solution. So this is the salt that we have. And we are going to put this solution, salt, just imagine into a beaker. We are diluting this one up to 250 cubic centimeter, 0.5 moles per cubic decimeter. Remember, in the laboratory, this is available as sodium thiosulfate Na2S2O3 5H2O. That's what we calculated. So it is actually available as a hydrated salt, and we need to prepare a solution like this. So if you find out the sodium thiosulfate moles in the solution, 0.5 moles per cubic decimeter multiplied by 250. 250 means 1/4 cubic decimeter. And then the answer is 0.1 0.5 divided by 4. What is the answer? 2 0.125. Okay, moles. Then we can find out. So these are the sodium thiosulfate number of moles. So what is the mass that we have to take? Remember, students, this is the compound available. So from this compound only, we have to take this much of moles. Then we do not consider about the water. Actually, water is already there combined with the compound, sodium thiosulfate. But it doesn't matter. We need to have only 0.125 moles of sodium thiosulfate, right? Then, since they have given this compound, molar mass of sodium thiosulfate 5H2, hydrated salt, we have to take the molar mass of them. Sodium thiosulfate molar mass, we know that is 158 plus water is 18 into 5. Sorry. So 158 plus 90, summation is equal to 5, 248 grams per mole. Then we have to find out the mass of hydrated salt, sodium thiosulfate, Na2S2O3, 5H2O, mass, right? 248 grams per mole multiplied by 0.125. That means 0.5 divided by 4 moles. 4 here. So this is divisible by 4. 62. Multiplied by half. 31 grams. Right? So that means we have to weigh 31 grams of this hydrated salt in the laboratory using a chemical balance. And it is added to a beaker or appropriate glassware and diluted up to 250 cubic centimeter. Then this required solution is okay. You can just write down that one as a statement in this way. 31 grams. Sorry, this is 3.1, no? 31. 248. This is divided by this one. 0.5 means half. Yeah, it's okay. Fine. 31 grams of sodium thiosulfate, 5H2O, salt, weighed using a chemical balance. And the sample is added to a beaker by diluting with distilled water up to 250 cubic centimeter level. That's how we can prepare the solution. Okay. So they're asking to use anhydrous salt. Explain briefly how you prepare 250 cubic centimeter of 0.5 moles per cubic decimeter solution using anhydrous salt of extraordinary. Okay, so they are asking only about anhydrous one. That means without 5H2. Right. Okay. That means we have to reduce this one. 158. Anhydrous means, students, actually water molecules are not trapped there, only the compound. So therefore here 12. For 38 we have 0.5. 39.5. So 39.5 divided by 2. 19.75. 19.75. We have to take 19.75 of anhydrous sodium thiosulfate. Okay. If it is hydrated, 31 grams. Okay, right? Yes, that is the answer. Asma? Yes. So with that question, Visakha Vidyalaya paper is also over. That means we have completed 3 papers. No? 1, 2, 3, 4 papers. How many papers we have completed? Royal College paper, the Royal College Devi Balika Vidyalaya paper, and Visakha. That means we have completed 3 papers. We have only 1 paper remaining. Quickly finish this one. And if you have any doubts, put your doubts in the chat box before we go for the next one. Quickly. Yes, Jaroshan, what are the doubts you have? Any doubts? Anything? What about using a volumetric flask instead of a beaker, sir? Yes, that's why I told you. We can use here, instead of a beaker, we can use a volumetric flask, doesn't matter. So normally volumetric flask is used to do a titration. Since we are not doing a titration here, we just need to prepare a solution. I used here beaker. But if you use here volumetric flask, earn in my flask, right? So anything you can use, any appropriate glassware. Understood? That's why I earlier mentioned you any appropriate glassware. So here I'm just using a beaker because I'm just preparing a solution only, right? Volumetric flask is used to do a titration. Since we are not doing a titration here, no need to mention that one. Okay, Nidhi. Rafa, I think you got the answer. And Jeroshan, what are the doubts you have? Right. Students, shall we move for the last paper? 2016 Anand College paper. Let's see. Right. First of all, structured essay paper. Question number 1, part A. Let's see. Identify the particles or the nuclides suitable for the blank cages. Hence, balance the following nuclear reactions equations. So we discuss about the nuclear reactions in the theory class also. Nitrogen 714 reacting with particle to produce oxygen 817 and hydrogen is produced. Second one, carbon 612 reacting with twice of a particle forming nitrogen 714 forming electron -10. And third one, aluminium 1327 reacting with helium 242 plus. Students, correct that one. That one should be helium 242 plus, producing a particle plus neutron 01. Fourth one, magnesium 1224, helium 242 plus, helium nucleus, that means alpha particles, forming a particle plus neutron. And the fifth one, fluorine 919 reacting with neutron 01 to produce a particle plus electron -10. I told you that when we are balancing a nuclear reaction, always you have to balance the atomic number and the mass number. Here mass number should be balanced with the mass number in the Y one, right? Here atomic number should be balanced with the atomic number in the other particle. So that is the only rule that we have to follow. Understood? Then by looking at the first one, go for the first one. You have to understand that one. In the right hand side, we have the atomic number 8, 1, summation is 9. Here we have 7. Then the remaining one should be 2. Then what about this one? 14 here. and here we have 18. So in order to get the summation, if you get the summation of 17, 1, 18, in order to balance that one, mass numbers, we have to put here. So what is 2 for? What is 2 for? Alpha particle, right? That means nitrogen, helium nucleus, not helium atom. That should be helium nucleus. So alpha particles are reacting with nitrogen to produce oxygen, isotope of oxygen, and hydrogen. Can you understand? Then what about this one? Carbon 612 is reacting with twice of one particle. Sorry, to produce nitrogen plus electron. So what should be the answer for this one? Here we have 7 minus 1, that is 6. That means the particle that we have here, this one should be 0. Because when you multiply 0 by 2, answer is 0. 0 plus 6, 6. And here 7 minus 1, 6. Definitely this particle should be 0. Atomic number. And here look at the mass number. 14, 0, 14. Summation is 14. Here we have 12. Then 12, if I put here 1 only, 2 multiplied by 1, answer is 2. 2 plus 12 is 14. Then who is the particle having relative charge 0, relative mass 1? Who is the particle? Neutron. Then this is neutron. Carbon 612 isotope is reacting with 2 neutrons in order to produce nitrogen atom and 1 electron. Try to understand. And the third one, aluminium is reacting with alpha particle. Helium nucleus means alpha particle. Then we need to balance this one. Look at this one. 13 plus 2, 15. And here 0, definitely this one should be 15. Okay. 27 plus 4, 31. Here we have 1. Then here 30. Who is the atomic number 15 in the periodic table? Phosphorus. Yes. Go for the fourth one. Summation. 12 plus 2, 14. Here 0. Definitely the particle should be 14 here. And here summation 28. Here 1. Then this is 27. Who is the 14th element in the periodic table? Silicon. Right? Look at the last one. 9 plus 0. 9. Here we have minus 1. In order to make 9, we have to put 10. 19 plus 1, 20. Here we have 0. Then this is 20. 10, 20. What is the atomic number 10th element? Neon. Yes. That's all. So these are the nuclear reactions that we need to balance. That's very easy. It's not difficult. Quickly complete that one. Let's move for the next question. Part B. How many electrons are there in a phosphorus atom that should match with the given condition? Right. That's very easy. Let's see. Part B. Question number 1, part B. Rome number 1, and here capital Rome number 1, when L equal 1. Right? So they're asking about the phosphorus atom. We know that phosphorus is 15, atomic number is 15. If I write down the electron configuration, 1s2, 2s2, 2p6, 3s2, 3p3, right? So therefore, 15 element in the periodic table. L equal 1. What does mean by L equal 1? We know that there are 4 types of quantum numbers: NL, ML, MS. So these are the 4 quantum numbers. Principal quantum number, that means representing the energy level, principal energy level, and L is representing the sub energy level, right? And ML is representing the orbital type, and M is representing the spin of the electron, right? Then L means sub energy level. So they have given L equal 1. And in L equal, if we know that L equal 0 means that is S. Okay? If L equal 0, that is S. If L equal 1, P. L equal D, 2. Sorry, L equal 2 means that is D sub energy. Then they are asking about here P sub energy. So how many electrons are there in P sub energy levels? You can see that here there are 6 electrons in 2p. In 3p sub energy level, there are 3 electrons. So altogether, there are 9 electrons. Answer is number 9. Try to understand. Very easy. Look at the second condition. Second condition they have given N equal 2 and L equal 0. That means principal energy level number 2 and the sub energy level is S. Second principal energy level, S sub energy level. How many electrons are there? How many electrons? 2. 2 electrons. Just 2 electrons. Next one. Atomic number of chromium is 24. Write down the electron configuration of Cr3 plus. Ayyo, what are these questions? Easy. These are very easy questions. Look at this one. We know that chromium is 24. First of all, let me write down the electron configuration of chromium. 1s2, 2s2, 2p6, 3s2, 3p6, 3d4, 4s2. But we know that this configuration is rearranging in order to obtain the greatest stability. So therefore 3d5, 4s1, right? Then, so chromium is forming chromium 3 plus cation by removing 3 electrons. So if it is removing 3 electrons, here 1 electron should be removed. From here 2 electrons. So therefore 3d3. Then the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d3. There are 3 unpaired electrons. Okay. Then, yes, this is the configuration. Problem number 3. In the Cr3 plus ion, how many electrons as Ms equal plus half? Look at this one. In this question, they are asking how many electrons are there with Ms plus half. Students, it's like this. Now, Ms plus half means we know that in an orbital there can be maximum 2 electrons. Okay? According to the Pauli's exclusion principle, he says that there are 2 electrons in the orbital and both of the electrons are having 2 separate unique quantum numbers which completely different from others, right? Then if one electron is rotating to clockwise, other should be counterclockwise. So they're asking in Cr3 plus cation, how many electrons are there with Ms equal plus half. Now come look at the total configuration. 1s2, 2s2, 2p6, 3s2, 3p6. If I consider, if you forget this 3d3, and if you consider this configuration, 1s2, 2s2, 2p6, 3s2, 3p6. In this configuration, all the orbitals are completely filled. That means all the orbitals are containing ms equal plus half and ms equal minus half, both electron. That means if you divide this one by 2, this configuration, I'm talking about this one. In the box, we have configuration 1s2, 2s2, 2p6, 3s2, 3p6. So here there are 18 electrons. In this 18 electrons, can we exactly tell that 9 electrons are having ms equal plus half? What do you say? Am I correct? Yes, we can exactly tell. We can exactly tell that among these configuration, among these electrons, among these 18 electrons, definitely 9 electrons should be ms equal plus half. But can we guarantee that these 3 electrons are also ms equal plus half? No, we can't tell. We cannot exactly tell that one. It can be either ms equal plus half or ms equal minus half. So therefore, we can have two answers here. What are the answers? We can tell that there are 9 electrons, or else we can tell that 12 electrons with these 3. So let me write down the answer here, 9 or 12. Because we don't know whether exactly these 3 electrons are rotating to ms equal plus half side or minus half side. So 9 is also correct. If someone consider that one is 12 also, that is correct. Doesn't matter. Okay, do you agree with me? Any suggestions? Anything? We can't exactly sure about these 3 electrons are what, plus half or minus half. Okay. So can we get an exact answer by writing the quantum numbers? No, we can't, because now up to here everything is okay. Now here the issue is with these 3 electrons. So here there are 3 unpaired electrons. So when you write down the quantum number for set for this one, someone can write down in this way: third principal energy level, d sub energy level means 2, orbital can be minus 2. Someone can write down this one as plus half, or else if someone write this one as minus half, that is also correct. So both are correct. We don't know exactly whether this electron is rotating to clockwise or counterclockwise. Okay? So therefore, no point of writing quantum number sets here. Try to understand whatever the method we follow, it can be either plus half or minus half. So therefore, we have two answers for this question, right? Right. Look at the next one. How many electrons are there? How many electrons has n plus 1 equal 4 and ms equal minus half? So this is also interesting. N plus 1 equal 4 and ms equal minus half. What is this? Right. First of all, let's find out n. What is n? N equal 3 and ms equal minus half. N equal 3 means third principal energy level. Inside third principal energy level, there are 8. Altogether, there are 11 electrons. And we know that exactly S sub energy level and P sub energy level is completely filled. So therefore, exactly we know that there are 8 electrons. So there are 4 electrons. There are 4 electrons with minus 1. Again, I can tell that these 3 electrons are also minus 1, minus half, or plus half. So therefore, we can include that one also. 7, 4 or 7. Without include that one, we will have what, ms equal minus half 4. If you include those 3 electrons as ms equal minus half, we can get the answer as 7. 4 or 7. Here 9 or 12. In the mark schemes, definitely they will give you answers. They will give you marks for these two answers. So that's the easy question. No? It's not very difficult. Right. Now let's move for the next question. Next question is related to the Lewis structures. Simple C. Skeletal of the molecule CX3, NCO is given below. Identify X. Draw the most acceptable Lewis structure for this molecule. Right. So simple C part. CX3, CNO. Carbon atom is connected to 3 X atoms. A nitrogen atom, carbon atom, and oxygen atom. And they have named the atoms. This carbon atom is named as simple A. This is simple B, simple C, and simple D. Right. So what is the first question they're asking? Identify X. Ayyo, very easy. Who is it? What is X? Hydrogen. Definitely, right? Because someone can say, sir, this is a fluorine. Chlorine. They can be fluorine, chlorine also. So if it is fluorine or chlorine, there should be what? Lone pairs. If there are no lone pairs, definitely this one should be what? Hydrogen. This is hydrogen. And the second one, draw the most acceptable Lewis structure for this molecule. Yes, let's draw it. A carbon is connected to 3 hydrogen atoms in this way, and then nitrogen, carbon, and oxygen. We know that if oxygen is connected to connected as a terminal atom, there should be a double bond. In order to satisfy the octet, here carbon should form another bond with nitrogen. That means there are 2 double bonds around carbon atom. And if you put a lone pair on nitrogen, everyone is satisfying the octet except hydrogen. Except hydrogen cannot have 8 electrons. Hydrogen is forming only 1. So this is the most acceptable Lewis structure we can draw for the given molecule. Draw 2 other resonance structures. Yeah, do you have any doubts? So though I know X has to be H, why can't it be another group 1 elements like sodium? The thing is sodium, lithium, sodium, potassium, rubidium, cesium like elements are not forming covalent bonds. They are only forming ionic bonds. So this is a covalent molecule. So how then X can be sodium? Have you seen that sodium hyphen chloride? Chloride? Is it possible? Have you seen like this? If I write down sodium chloride in this way, Na hyphen Cl. Is that correct? This is one of the way that we can kill chemistry on the spot. Understood? Actually, this is actually we are violating the basic rules in chemistry. Okay, so this is wrong. Varadi wrong. So therefore, X cannot be a first group element. That should be definitely. Number 3, they're asking about 2 other resonance structures, how we can draw them. So what we can do is we can play with these 2 double bonds. What about if I shift one of the bonds from carbon oxygen to nitrogen carbon? That means triple bond here, single bond here, and single bond here, triple bond here. Neither we can play with the bonds. So remember always when we are drawing the resonance structures, total number of bonds can be kept constant. So here what we are going to do is, I'm going to shift the bonds here and there. But here we have to be very careful with the lone pairs and the charge. Here oxygen is negatively charged. Here oxygen is positively charged. Nitrogen is negatively charged. Carbon is satisfying the octet. Right? They're asking draw 2 other resonance structures, Lewis structures that can be external molecule than the above one. Right? We can draw another one. When we are drawing the resonance structures, I always told you that, remember, we have to put this double-headed arrow for both sides. And the second one should be, we can put the triple bond between nitrogen and carbon and single bond between carbon and oxygen. So then here oxygen is negatively charged, nitrogen is positively charged. So, right. So this is connected to the next question also, but let's see. Among these two molecules, so which one is stable and which one is unstable? Which one is stable and which one is unstable? We can say that definitely this one should be unstable. Why? What is the reason? So among the elements, oxygen is the most electronegative atom. So then how oxygen can get the positive charge? So therefore that is unstable, since as oxygen has the positive charge. So this is very stable. The reason is as oxygen has negative charge, because oxygen is the most electronegative atom here. So if it has the most, if it is the most electronegative atom, if it is get the negative charge, that is stable. What is the most stable structure from the above two structures? Definitely, the second one that we have drawn is stable, right? Sir, why is it hydrogen? Why can't be chlorine or fluorine? Just now I explained you, right? If it is chlorine or fluorine, there should be lone pairs. Around X, are there any lone pairs? No, right? So therefore, we cannot be fluorine or chlorine. If there are lone pairs only, we can take chlorine and fluorine. Mariam, I explain you that one. Okay, listen to the things. Give reasons for your answers, right? So the reason is, in the second structure, oxygen atom has the negative charge. The most electronegative atom has the negative charge. In the first structure, the most electronegative atom has the positive charge. So that is the reason. This paper is easy again than the previous ones. I think next week we have to go for a new book. That means tomorrow I have to prepare the fourth book. Let's find some papers. Okay. WC papers. Anand, Will, Sakadi. Yes, Asma, that is my plan actually. In the next paper book, you will see that most of the papers will be FWC. So why you are giving that much priority for the FWC? Because students, FWC papers are made by the North Province. Actually, those papers are very standard, highly standard papers, right? Always I'm recommending you, there are a lot of FWC past papers in the internet also you can download, okay? And you can suggest me, sir, to do, sir, do this one, do this one. Likewise, you can suggest me. If not, I won't do. All together, you discuss all and tell me, sir, we want to do this paper, then I will discuss. I will include that paper in this paper book. If not, I won't discuss. But I think that from my side, I have to do something like that, because we have to go with the trend. Normally, FWC papers are very standard, highly standard. And Royal College papers are also highly standard. Highly standard means simply we can say they are difficult, right? So by discussing those kind of difficult questions only, you are practicing to think. Your brain is going to work. If not, your brain is always at the same time. You don't collect the knowledge. You don't have any improvement. So we need to see the improvement. Now, the one more thing, some of you told me that, sir, chemistry exam was easy, but I couldn't manage the time. I heard this one from many students. This time, when you get the first term examination, paper was easy, can manage. The questions that we discussed also came to the paper, but time management is the issue, right? So we have to do something for this one. I'm planning to do something for that. Let's see what we can do. I will explain that one in theory class as well as in the paper class in upcoming days. Okay, right? So we have to plan something big to do that one. Yes. So I have this here Royal College paper. Ane, send will you? Shall I send it to you and can you please mail it? Yes, yes, please send it. If you have the paper, please send it. Students, don't hesitate to put the papers that you get from your school to our WhatsApp group. Okay, you can share that one with me personally or with the friends in the group. Doesn't matter. Please share that one and let's have the discussion on those papers. Right. I will include that FWC paper that you sent me. I told you that we have to discuss that one. I couldn't discuss that one, so I'm going to include that paper in the next paper book. So therefore, please, if you have any papers, tell me. We have to use the paper class to discuss a lot of questions, school term test papers, provincial papers, everything. Rafa, send me that one, okay? Royal College paper. Right, okay. Next one, Rome number 5. So in Rome number 5, they're asking to fill the table. Electron pair geometry, hybridization. That's all. Carbon atom, nitrogen atom, carbon atom, and oxygen. So what was the Lewis structure? The stable one. So this was the stable one. A, B, C, D. Electron pair geometry, we know that that is a tetrahedron. A hybridization, 1, 2, 3, 4, 3 Vesper pairs, therefore sp3. Nitrogen atom, electron pair geometry, 1, 2, 3, 3 Vesper pairs are there. So therefore electron pair geometry is a trigonal plane. And what is the hybridization? sp2. Next one, carbon atom. There are two Vesper pairs, electron pair geometry is linear. Hybridization is sp. Oxygen, we can tell that 1, 2, 3, 3 Vesper pair, 2 Vesper pairs. So therefore electron pair geometry is linear. And hybridization, if we talk about the hybridization, 1, 2, 2 Vesper pairs are there, sp. But we know that this is considered as terminal atom. So we can consider that either this is hybridized or not hybridized. If it is hybridized, if we consider this one is hybridized, electron pair geometry linear, hybridization is sp. Right. That is the that is all about the first structure as a question paper in this one. So that is very easy. I think this is the easiest structure as a paper we discuss. Quickly. So have you written the answers based on the unstable structure? Unstable structure means what? Under the resonance structure. So this is the one. No? Unstable one was, oh yeah, I erased that one. Under the unstable one, remember Hitach, that should be as oxygen atom has positive charge, right? Under the unstable structure, I wrote that there as oxygen atom has positive charge. Oxygen should have 2 lone pairs. Ah, yeah. Sorry. So then this is actually not linear. Eh? 1, 2, 3. trigonal plane. And the hybridization is sp2. Sorry. That is the correct answer. Very good, Maria. Others are okay. There should be 2 lone pairs on the correct structure. Right, okay. Shall we move for the second structure as a question? Arrange the following in the increasing order of the given property in the brackets. Manganese, chromium, vanadium, iron, unpaired electrons of the elements. Easy. Look at this one. Second structure is a question. Manganese, chromium, vanadium, iron, unpaired electrons of the elements. Right. When you consider manganese, what is the valence configuration? 3d5 4s2. What is the chromium? 3d5 4s1. What is vanadium? 3d4 4s2. That 3d3 4s2. Then iron 3d6 4s2. Now tell me how many unpaired electrons are there. In manganese, there are 5 unpaired electrons. In chromium, there are 6. Vanadium, 3. In iron, 4. So therefore, the greatest number of unpaired electrons belongs to chromium, then manganese, and then iron. The least number of unpaired electrons belongs to vanadium. So this is the correct variation in the increasing order. Right? So by identifying the valence configuration, you should be able to get the answers direct. Second one, sodium plus magnesium 2 plus F minus and aluminium 3 plus ionic radius. I told you many times before, when you are given to compare the radius, always count the electrons. Right? That's what you have to do first of all, because you have to identify whether they belongs to the same period or not, whether they are in isoelectronic series or not. So first of all, when you consider sodium plus, how many electrons are there? 10. Magnesium, 10. Chloride, 10. Aluminium, yes, all of them are in isoelectronic series. So therefore, we don't have to worry about that one. You can just take the nuclear charge, that means number of protons, sodium 11, aluminium, magnesium 12, fluorine 9, aluminium 13. So when the proton count increases, means definitely the nuclear charge is increasing. When the nuclear charge increases, what will happen to the atomic radius? Atomic radius is decreasing, right? Then tell me which one has the highest radius, which one has the least number of protons? F minus. Then F minus has the greatest ion radius, and then we can take sodium plus. Then we have magnesium 2 plus. So finally we have aluminium. So this is the correct variation for the ionic radius. Easy. Then we have atomic radius. Atomic radius. Oxygen, sulfur, neon, silicon, atomic radius. So same thing we have to repeat. First of all, count the number of electrons. Let's see. electron oxygen 8, sulfur 16, neon 10, silicon 14. So therefore, this is not isoelectronic series. They have different number of electrons. For example, let's go for the periodic table: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. So what are the elements that they have given? Oxygen, sulfur, neon, silicon. Right. Now look at this one. Remember, students, definitely sulfur and silicon, they should have the greatest radius. Why? The reason is they are belongs to the third period. Among sulfur and silicon, which one is the greatest radius? Among sulfur and silicon. Among sulfur and silicon, which one is the greatest radius? Silicon. And then we have to put the silicon. Silicon has the greatest radius. Then sulfur. Now go for the second period. If you go for the second period, which one has the greatest radius then? Oxygen and neon. We know that atomic radius decreases along a period, right? That's how you choose the radius between silicon and sulfur also. Along a period, atomic radius decreases. Down to the group, atomic radius is increasing. So therefore, next one should be oxygen, and the least radius belong to neon, right? So it's confirmed that down to the group also atomic radius increasing. Look at oxygen and sulfur. Oxygen and sulfur, they are belongs to the chalcogen group. So oxygen, sulfur, oxygen is actually above sulfur. So therefore, sulfur has the greatest radius. So it's explained by the answer given. So this is the way that atomic radius is increasing. Under the atomic radius, you have to always remember two rules. Remember, students, what is it? Along the period from left to right, atomic radius is decreasing. Down to the group, top to bottom, atomic radius is increasing. Those are the two basic rules. Right. Next one. First ionization energy. Yes. Actually, I was wondering why there is no question related to the ionization energy. Yes, now we have. Carbon, boron, beryllium, nitrogen, they are in the same period. So therefore, zigzag variation, can you remember? Lithium, now these things are nothing for you neither. Beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon. So you can see the same variation for the third period elements also. So what are the elements they have given? Carbon, beryllium, boron, nitrogen. So ionization energy, the highest one belongs to from number 4, nitrogen. Next one is carbon, beryllium, boron. Okay. Problem number 5, ammonia, H2O, methane, boiling point. Boiling point. So when you compare the boiling point of these compounds, so these are covalent compounds. So therefore, you can go for the secondary interactions, right? So when you consider the secondary interactions, first of all, let me draw the molecules. Ammonia NH3 in this way. Water molecule is in this way. And methane is like this. Methane molecule is tetrahedral, and this is a non-polar molecule. So between the non-polar molecules, what are the interactions that existing? Between the non-polar molecules, methane, what are the interactions? Quickly. What are the possible interactions? London forces. Remember, students, London forces are not that much stronger when you compare with the other secondary interactions. So therefore, we have to give the least priority. That means the least boiling point belongs to methane. And what do you know about water molecule? Water molecule is actually having a pole, dipole, and ammonia also having a dipole. But we know that specifically we learned that ammonia, water molecule has what? A greater boiling point, 100 degrees Celsius, because of the existence of hydrogen bonds, right? But ammonia also can form hydrogen bonds. But ammonia hydrogen bonds are not stronger than water molecule, because electronegativity difference between oxygen and hydrogen is greater than the electronegativity difference between nitrogen and hydrogen. So therefore, even though that ammonia also forming hydrogen bonds, water molecules are having a greater number of hydrogen bonds, and the strength of the hydrogen bonds also increasing. Therefore, the boiling point is about 100 degrees Celsius. Ammonia is not like that. Okay. Then ammonia is the second highest one. So water molecule has the greatest boiling point among these three compounds. Got it? That's the way. Hydrogen bonding network is there in H2O. But ammonia is more volatile. Can this be the reason, sir? Hydrogen bonding network is there in H2O, but ammonia is more volatile. And this is the reason. Yeah. So finally, the ultimately we can tell that Rafa, it's like this. Now think about their physical nature. Now in the room temperature, water is a liquid under the room temperature. That means about 25, 27 degrees Celsius. Okay. Water molecule is a liquid. Water is liquid. And ammonia is a gas. We know that in water molecules, liquid is, the molecules are a little bit closer to each other. But ammonia, the molecules are a little bit apart from each other. Molecules are apart from each other. So the reason is, again, the strength of the hydrogen bonds. Water molecules are forming highest intensity of the hydrogen bonds. They are close to each other. Their hydrogen bond strength is more powerful. So therefore, they are existing as a liquid. As you mentioned, that is a network of hydrogen bonds. Yeah, we can tell like that. But ammonia is not like that. Ammonia, nitrogen, hydrogen electronegativity difference is low. So therefore, the hydrogen bond strength of the hydrogen bond is low. Understood? So that can be the reason. Right. And number 6, ammonia, ammonium and amide, electronegativity of nitrogen. Ammonia, ammonium and amide. We have to compare the electronegativity of nitrogen. Right. So we know that there are 4 factors affecting to the electronegativity. Can you remember? Electronegativity is depending on the hybridization. And it is depending on the formal charge. And the oxidation number. And the next one is nature of surrounding atoms. So these are the 4 factors that affecting to the electronegativity. Remember, students, when this character increases, when you compare sp2 and sp3, in sp hybridization, S character increases, therefore electronegativity is increasing. Formal charge also, when you consider plus 3, plus 2, plus 1, plus 3 atom has the highest electronegativity. That means when formal charge increases, electronegativity is increasing. And oxidation number is also behaving as the formal charge. When oxidation number increases, electronegativity increases. And when you consider the range of the surrounding atoms, if the central atom is connected to a more electronegative atom, then the central atom is also more electronegative, because the central atom becoming more positive, therefore it can easily attract the electrons. Now if you go for the three species, they have given ammonia, ammonium, and amide. All of them are having the same hybridization, isn't it? sp3, sp3, sp3. So therefore hybridization is not the factor. Did you notice that one? You can directly go for the answer by considering the formal charge. Here nitrogen is having zero charge. Here nitrogen is having plus charge, and here nitrogen is having negative charge. And then you can get the answer. So who is the highest electronegative atom? Nitrogen in ammonium cation. And the second highest electronegative atom is ammonia. And the third one, least one, is amide, because their nitrogen's charge is minus 1. So we can have this kind of variation. Yes. Yeah. Okay, right. So shall we have a break? Yes. Let's have a 10 minutes break. 10 minutes break, okay? Now time is 5:05. After 10 minutes, let's start the class. Yes. Have a break quickly. Right, okay, students, shall we start? Right, okay. So this is the part A of the question number 2. Let's move for the part B. Define the first ionization energy of an element. So how we can define this one? First ionization energy. Let's see. We have learned this one in first unit. First ionization energy, I1. First of all, let's define the first ionization energy using an equation. Gaseous state 1 mole of M is forming gaseous state monovalent cation by releasing 1 mole of electrons. So this is considered as what? First ionization energy, I1. So that is considered as first ionization energy, right? We can write down in this way. The minimum energy required to remove 1 mole of electrons from 1 mole of M gas, gaseous state M gas, to form 1 mole of monovalent M plus gaseous state cation. The minimum energy required to remove 1 mole of electrons from 1 mole of gaseous state M to form 1 mole of monovalent gaseous state M plus cation is considered as first ionization energy. In this way. Okay. Chrome number 2. Successive ionization energies of the naturally existing element A is given below. So the values are given 1402, 2856. So likewise, they have given some values. Sketch the variations of successive ionization energies of the element A by labeling the axis. Give the reason for the common variation of the ionization energy of the element A. Deduce the group in the periodic table. What is the minimum valence that can be accessed for A, right? Okay, that means we have to draw the graph, right? First of all, write down this one. If we analyze the values, first of all, let's analyze the values that they have given. 1402, 2856, 4,578, 7,475, 9,445. Suddenly it increased to 53, 3,266. Then 64,360. So between these two, we have a large gap, right? So between these two, what is the gap? Here we can consider the gap is 4, 5, 4,454. Between these two, what is the gap? 8, no, 2, 2, 7, 1. Almost same. What about these two? Between these two, the gap is 7, 9, yeah, gap is increasing 2,897. And here the gap, we can say that 0, 7, yeah, 1,970. And what about these two? Look at here. Here only we can see the large gap. Yeah, no need to consider about these two. Here only we can see the very large gap. Right? And again, here we can see 2,897, another gap, small gap, slightly large gap, slightly large gap. Right? Because it's continuing 1,454, 1,772, 22, and then again suddenly it increases to 2,897. Then we can draw the graph in this way. Look at the graph. You have to analyze the gap. We discussed this question in the first unit. Look at this one. We can take the y-axis as successive ionization energies. Energy. And as the x-axis, we can take electrons, number, the electrons removed. Right? So the first value is this one, 1,400, 1, 2, 3 in this way. This way. It suddenly increases in this way. And again, we have a larger value. Right? So this kind of a graph that we can see. They're asking only rough sketch, right? So this is the first electron that we removed. Therefore, I1, I2, I3, I4, I5, I6, I7 in that. You can see that this is the very large gap that we obtain, right? If you obtain very large gap in the ionization energies, remember students, always you are shifting from one energy level to another energy level. That means these two electrons are belong to another principal energy level, and these electrons are belong to another principal energy level. If you have a slightly large energy gap, what you can think? You can say that these two electrons are belong to a sub energy level, and these three electrons are belong to another sub energy level. Yes, the separation of the sub energy level. So we can tell that definitely these 5 electrons are belong to p sub energy level, because 5 electrons are there. Maximum there can be 6 electrons, and these 2 electrons are belong to S sub energy level. Then the configuration is S2 P5. right? Here we have me, sorry, sub energy level means we can tell this one as S and this is P. Then we can tell that S2 P3, right? So these are three electrons, S2 P3, S2 P3. Okay. S2 P3 configuration. Then tell me, give reasons for the common variation of the ionization energies of the element capital A. Give reasons for the common variation of the ionization energies of the element capital A. What is the common variation? Common variation is successive ionization energies are increasing, right? So we can give the reasons like this. Common variation means an ionization energies are increasing, right? One by one, it is increasing. That is the common variation. Commonly, we can say that one successive ionization energies are increasing, right? What is the reason? We know that we can say like this: successive ionization energies, energies are increasing. That is the common variation. What are the reasons? The reasons are, we know that the electrons are closer to the atomic nucleus, to the atomic nucleus. Therefore, energy required to release electrons one by one increases. Right? We know that the energy required to remove this electron, first electron, so that is lesser than the energy required to remove the second electron. The reason is these electrons are more closer to the atomic nucleus. When you consider these two electrons are very close to the atomic nucleus. That's why they have that kind of large values, right? Right. Deduce the group in the periodic table that A belongs in the periodic table. So what is the group? As I mentioned you, I told you the configuration is S2P3. Then tell me what is the group number? Group number 15. Yes, this is group number 15. What is the minimum valence that can exist for A? Minimum valence. Minimum valence that can exist for A. Valency. Valency means bonding capacity. If I ask you what is the maximum valency for the group number 15? So what are the group number 15 elements? Nitrogen, phosphorus, arsenic, antimony, bismuth. Okay. So that is those are the elements. So the maximum valency for the group number 15 elements is 5. And the minimum valency is 3. Right? Ammonia, nitrogen is connected to 3 hydrogen atoms. So therefore minimum valency is 3, maximum valency is in that way. Okay. Try to understand. Right. So that is the B part. They have given this one related to the ionization energies. If you have any doubts, tell me. Quickly complete this one. Right? Are we done? Shall we move for the next question? We have to fill a table. State the intramolecular forces within the species, and the intermolecular forces, those exist in the following species. Right? Okay, right. Intermolecular forces and the intramolecular forces. Intermolecular forces mean between two molecules in a compound. What are the interactions? Intra means inside the molecule. What are the bonds we have? The primary interactions. Whether it is ionic covalent dative covalent metallic, you have to define that. Right? Let's see. Species, primary interactions, and then we have secondary interactions. So we have sodium chloride, first one. What is the primary interaction we have? Definitely ionic bonds. Do we have any secondary interactions in sodium chloride molecule? No. Carbon disulfide. Carbon disulfide. What is the primary interaction? Covalent bonds. What are the secondary interactions that exist in carbon disulfide? Carbon disulfide. What is it? Carbon disulfide is like this. So this is non-polar molecule, a symmetrical molecule. This is not polar molecule. So therefore, the secondary interaction type is London forces. Only London forces. Next one, PF3, covalent bonds. PF3 molecule is like this. Phosphorus is surrounded by 3 fluorine atoms, and around 1 fluorine atom, there are 3 lone pairs. What do you think about this one? So this is exactly a polar bond, polar molecule. So therefore, definitely dipole-dipole interactions are existing. Dipole-dipole interactions. Addition to the dipole-dipole interactions, we have London forces also. Because I told you that between any kind of covalent compounds, we can see London interactions, London forces. Next one, xenon tetrafluoride. Xenon tetrafluoride, if I draw the Lewis structure first of all, so this is the structure. What do you think about this one? Whether it is polar or non-polar? This is polar or non-polar? Non-polar. Since this is a non-polar structure, we can tell that the secondary interaction type is only London forces. No dipole-dipole interactions. So definitely covalent bonds are there as primary interactions. Next one, bromine, Br2. Bromine, what is it? Covalent bonds. Bromine atom is connected to another bromine atom. Polar or non-polar? Of course, that is non-polar. Interactions, London forces. Next one, CH2Cl2. Carbon is connected to two hydrogen atoms and chlorine atoms. So this is a polar molecule, covalent bond. And since this is polar molecule, definitely dipole-dipole interactions are existing. Dipole-dipole interactions. If it is polar, definitely dipole-dipole interactions. And then we have London forces for sure. So this is the table. So why can't sodium chloride have iron dipole interaction? Okay, sodium chloride molecule, that means this is sodium chloride solid, NaCl solid, isn't it? The natural form of, so they have given that intermolecular X in the following species. We have to assume the natural compound sodium chloride solid. In order to make iron dipole interaction, there should be a polar molecule which is making covalent bond. So tell me, where are the polar molecules in order to make iron dipole interaction? If there is only sodium chloride compound, so where are the covalent molecules? When it is dissolving in water, then we can tell iron dipole. Sodium plus cation is surrounded by water molecules. Can you remember? In theories, Cl minus is surrounded by chlorine, water molecules. Yeah, when we consider aqueous state, that means when we dissolve that one in water only, we have to consider iron dipole interactions. But here they have given the only natural substance, sodium chloride solid. So in that we have sodium plus cation and Cl minus an ion, and that we have what? Ionic bonds. So in CH2Cl2 doesn't have dative covalent bonds. No. What are the questions you ask me? CH2Cl2, how it can be a dative covalent? This is the CH2Cl2 molecule. Right. Okay. So that is the so how to reduce the last one is polar. Yes. Look at this only. Now you can see that when you consider the CH2Cl2 molecule, in order to become non-polar, the resultant dipole moment should be 0 in order to become non-polar. In this molecule, who is pulling electrons? Carbon is pulling electrons. Chlorine is pulling electrons from carbon, and here also chlorine is pulling electrons. And when you consider carbon-hydrogen bond is again polarized. Carbon is pulling electrons than hydrogen because carbon is the electronegative atom than hydrogen. So therefore, here you can see that the resultant dipole moment is somewhere like the downward direction, right? For the downward direction, that means resultant dipole moment is not equal to 0. If the resultant dipole moment is not equal to 0, the molecule is polar. Okay. So that structure recipe is very easy, hard. So why xenon tetrafluoride doesn't have dipole-dipole interactions? The reason is xenon tetrafluoride is not polar. That is not polar molecule. If it is polar only, dipole-dipole interactions are existing. If it is non-polar, the only interaction type is non-nut process. Right, okay. Next one. Essay paper, question number 3. Why is an element with atomic number less than 20, Y is not actual symbol of the element. The element capital Y forms two compounds, YF4, YO2 with fluorine and oxygen respectively. Skeletal of the compound are given below. I think they are they are expecting us to find out why, right? In question number 3, who is Y as you think? In question number 3, who is Y? They have given Y is less than 20 atomic number. Y is making 4 bonds. Y is connected to 4 fluorine atoms, and there is a lone pair on Y. Y is connected to 2 oxygen atoms, and there is a lone pair on Y. Let me see your answers in the chat box. Put your answers. Rafa correct, Lashmi correct. That is the answer. What about the others? Quickly. Sinetma correct, Shala correct, Akash correct. What about the others? What is this? Sulfur. Yes, this is sulfur. We know that sulfur is forming sulfur tetrafluoride, SF4, and sulfur dioxide. So sulfur tetrafluoride, if I draw with the correct shape, this is the structure. There is a lone pair on sulfur atom, and there are 3 lone pairs around the fluorine atom. In this way, and this shape is seesaw. When you consider sulfur dioxide, sulfur is surrounded by 2 oxygen atoms. And on sulfur atom, there is a bonding pair. And this is angular shape. Right? So therefore, Y is nothing else but sulfur. Let's move for the B part. Arrange the following in the ascending order of the properties. Those are given in the brackets. Number 1, magnesium, aluminium, silicon, second ionization energy, I2. Right. Magnesium, aluminium, silicon, all of them are in the same period. If I start from, let's right. How about now? Can you hear me? Now, okay. So, students, these are the first ionization energies of third period elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Right. So, in order to obtain the second ionization energy, I'll denote that one in blue color, I2. What we have to do? You have to put the elements backward. That means magnesium should come here. Aluminium should come here. Silicon should come here. Phosphorus, sulfur, chlorine, argon. in this way. So they are asking to compare the second ionization energies. Magnesium, aluminium, silicon. Who has the highest second ionization energy? Aluminium. Next one, silicon. Least one belongs to magnesium. This is the correct variation of the second ionization energy. Okay. Try to understand. That's very easy. Huh? Hmm. Hmm. Those who face for the term test examination, now you may have understood what is the importance of the paper class, isn't it? What do you think about that one? Those who face for the term test examination. Can you understand the importance of doing papers rather than learning theories? Learning theories are, yes, compulsory. It's a must. You must learn. But additionally, you have to do the papers also, right? So you have to do that one by alone. So, but I'm guiding you here. You must understand to how to answer for a paper. Okay. Choose many papers. Do the lot of papers. How much you do the papers, that much you will be preparing for the A-level examination. If we didn't start this, I don't think I may answer even half of the paper. Yes, that's why. For the 26 batch also, I'm planning to start that one very soon, paper class, online paper class, very soon, right? So your paper class will be continued in this way until the examination. Let's finish the theories quickly. At least before 6 months exam, let's finish the theories in the theory class, okay? And in the remaining 6 months also, we are going to continue the paper class until the exam. So that is my plan. Let's do a lot of questions. By doing a lot of questions only, you can prepare for the exam. That is the only way, right? Learning theories are okay because theories are okay. Theories actually we learn, everyone we learn theories. So that is not the case. Doing questions is the most important thing. I'm planning to start paper class, past paper class. I want to start that one, but the thing is time. I don't have enough time to do that class. I want to discuss past papers and I want to do that one as a free class. But let's see whether the academy is allowing me to do that one. Anyhow, I'm going to plan to do that one. Probably that will be live streaming in my YouTube channel also. Because we are not discussing past papers in our paper classes, right? In our paper classes, I'm discussing only the model questions, school term test, provincial paper. Past papers actually we have to do separately. So you actually you have to take the responsibility of doing past papers. Now you have to try the past papers. Now we have covered 3 complete units. You have the knowledge, so you have to do them, right? So my next plan is to do the 2012 to from 2012 11 to 2023. There are how many question papers? We have 12, 13 papers. With the 11, 2011, 13, 14 වල පටන් ගත්තොත් 10යි. ඔකට 11, 12, 13. Yes, we have 13 papers. So Did you try to do the past papers chemical calculations essay question that they have given from 2011 to 2023? Right? Actually, this is my dream. Right? This has become my dream. Why? It's very difficult to find out to discuss these 13 questions, because if I can discuss these 13 questions with you, you will understand the examination pattern and you will prepare for the chemical calculation question nicely. But anyhow, before you go for the examination, I'm going to do this one, right? I'm going to upload all the 13 recordings in the YouTube channel. Anyhow, I will do. That is one of my targets for your batch. So the advantage can be gained from the other badges as well. And that means upcoming future badges. 26. Now 26 online badge is nicely going. My target was completed. Actually, my target was when I'm starting your batch, my target was about 30 wage, to take 30 students wage, but I managed to collect 40 students in our theory batch. Now in 26 batch, there are about 60 students, those who joined for the class by paying. So therefore, I'm really happy. My target was to do the class for 50 students, but more than that there. Right. So anyhow, in future batches, sometimes we can go for the 100 likewise. That means students understand what is the quality online class, right? So that's happy to say. Right. So anyhow, remember students, doing past papers, doing papers are very important, right? So let's do this one anyhow. Let's make a plan for this one. Okay. We have to do this one. We must do this. Not now in within 5 months wage, I'm going to increase the paper class time also, about 4 hours wage. Theory class will be same time, 3 hours is enough. But paper class, actually, we have to do a lot of papers and questions. No? So therefore, let's increase that one to 4 hours or 3.5 later, not now. Right. So this is about the second ionization energy. Next one, carbon monoxide, carbon dioxide, and carbonate electronegativity of the carbon atom. So we discussed about the electronegativity previously. There are 4 factors: hybridization, formal charge, oxidation number, and the surrounding atoms. So how we can compare the electronegativity of these species? By looking at the molecule, can you tell that what is the hybridization, formal charge, and everything? Can you guess without drawing the Lewis structures? Everyone try that one. Without drawing the Lewis structure, try to obtain the hybridization. If I consider the hybridization, right? Carbon dioxide, carbon monoxide, and carbonate. Sorry. Carbon monoxide hybridization is sp, and carbon dioxide also sp, and carbonate is sp2. Neither. And what about the charge, formal charge? In carbon monoxide, carbon's formal charge is -1. This is 0. And here, 0. I think these 2 factors are enough to compare the electronegativity, right? When S character increases, I told you that electronegativity is increasing. Therefore, carbon monoxide and carbon dioxide should have the greatest electronegativity carbon atoms. Among these 2, which one is more electronegative? Carbon dioxide. Why? It has the greatest formal charge. And then the variation should be carbon dioxide and then carbon monoxide. And the next one should be carbonate, CO3 2 minus. In this way. So charge of carbonate is -2, right? No. Look at this one. This is carbonate anion. This -2 charge belongs to whom? Oxygen, not for the carbon atom. Understood? So what about oxidation number? No need to consider oxidation number. Why? Oxidation number with the hybridization and the formal charge, we can go for the answers. Right? First priority is given for the hybridization, formal charge, oxidation number, nature of the surrounding atoms. Right, Rome number 3. Nitrogen, phosphorus, sulfur, fluorine, chlorine. First electron affinity. Students, correct that one as first electron gain energy. Because now they are not asking the questions from the affinity. They are asking the questions from the electron gain energy. Okay, so therefore, please correct it as electron gain energy. Rome number 3. Nitrogen, phosphorus, sulfur, fluorine, chlorine. First electron gain energy. When you compare the first electron gain energy, I told you that always nitrogen, beryllium, and magnesium, they have positive values for the electron gain energy. So therefore, the largest one will be what? Nitrogen. Then what about phosphorus, sulfur, fluorine, chlorine? What about they? We know that sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Right? The negative value of the electron gain energy increases increasing from left hand side to right hand side. The negative value. Right? So that means we know that chlorine has the highest electron gain energy among the elements. So therefore, we can say that chlorine, when you consider chlorine, that is minus 349. Right? Then we have phosphorus, sulfur also. Right? These are not correct values. Let's assume that sulfur is minus 320 and this is minus we can say that this is 3 minus 310. Yeah, in this way. Understood? So that means the negative value is increasing for this direction. Then what is the highest value then among these three? If you consider first electron gain energy, what is the highest value? Phosphorus, ne? Phosphorus, sulfur, chlorine. Because chlorine going behind, since it is a negative value, we have to consider with the negative sign. And one more thing, we have fluorine also. What do you think about fluorine? Fluorine also having down to the group electronegativity is decreasing. That means the value is decreasing. But fluorine has negative less value than chlorine. Then we can consider in this way. Highest one belongs to for nitrogen, then phosphorus, sulfur, fluorine here, and then chlorine. Because the highest negative value belongs to chlorine. But when you compare fluorine, fluorine has a little bit higher value, higher negative value than sulfur. Let's assume that minus 330 in that way. Okay. We are assuming that fluorine should have the greatest value, but it is not fluorine. Fluorine has the greatest negative value of the first electron gain. Okay. Let's finish the remaining two parts also quickly. Atomic radius, aluminium, phosphorus, sulfur, oxygen. Aluminium, phosphorus, sulfur, oxygen. I told you that in order to compare the radius, always we have to take the electrons. 13, 15, 16, 8. Okay, they are not in isoelectronic series, but we know that students, oxygen belongs to the second period. So therefore, it has the least radius. What about aluminium, phosphorus, sulfur? Aluminium, phosphorus, sulfur, they are in the same period. Then we know that along a period, what will happen to the radius? Radius is decreasing. So therefore, the least radius belong to sulfur then among these three, phosphorus and aluminium has the greatest radius. Number 5, NO, NO2 plus and NO3 minus bond distance. This is also easy. Draw the Lewis structures. NO molecules look like this. Nitrogen is having unpaired electron. NO2 plus is look like this. Double bond is there. Positive charge. NO3 minus, it's like this. Negative, negative. Positive on nitrogen. There are two lone pairs on this oxygen atom and there are 3 lone pairs for this one. In this way, right? And they're asking which one has the highest bond distance. Now look at this one, students. This is very easy. When you consider NO and NO2, here we have bond double bonds, and here also we have double bond. And can you see that here we have nitrogen oxygen double bond as well as single bond. I told you that always single bond length is greater than double bond length. Double bond length is greater than triple bond length. Then if there are single bonds in the molecule, definitely that molecule has the highest bond distance, bond length. NO3 minus has the greatest bond distance. But when you consider NO and NO2 plus, what you can see here, right? It's like this. Now you can see that here we have only one double bond, but here we have 2 double bonds. That means electrons are separated. Electrons are distributed more. And the next thing is nitrogen is having positive charge, which means nitrogen is more electronegative, right? So oxygen is pulling electrons from the both sides. So since the electron distribution is high between 2 oxygen atoms, we can say that the bond distance in NO, in NO2 plus molecule is greater than NO molecule. So therefore, NO2 plus has the next one and NO has the least bond distance. So that means the same order that they have. Try to understand. Here there are 2 NO positions. Here we have just one NO position, just permanent double bond. So if you want, you can shift this one into a triple bond and single bond, and this one into a single bond and triple bond. So therefore, there is a chance to make single bond also. So therefore, we can tell that this is actually greater in distance than NO molecule. Okay. So you have to think that one very practically using your GK. Right. Okay. What are the doubts you have? Anything? Sir, sign value doesn't represent that the value is positive or negative, no? If represent whether the energy is absorbed or energy, right? So highest electron gain into chlorine, right? Yes, that's correct, Rifa. So first electron gain energy, if you consider that one, yeah, the value wise, if I consider with the value, the least value go for the chlorine. Yeah, with the value or without the value. Yeah, it's like this, no? Remember, students, when you consider the electron gain energy, sometimes we have negative values and sometimes we have positive values. So the negative values are representing that the electron gain energy is exothermic, and positive values is representing that is exothermic. So therefore, if you consider with the values, with the sign, chlorine go behind. But here actually they are asking about the electron gain energy, no? That means only the value, ne? So therefore we have to take the opposite of this one, students. That means chlorine should come here, then fluorine, sulfur, phosphorus, and nitrogen. Yes, that is the order. That means the negative and positive signs are representing whether it is exothermic or endothermic. Since they are expecting only the value here, chlorine has the greatest value. That means the completely opposite of the answer that I gave. Yes, Rifa, you are correct. Very good. Thank you for reminding me. Very good. Okay, so this is the correct order. That means try to understand we are only considering the value. With the sign, if you consider, that means other way. Anything else? Right. We have to discuss some other questions in this paper, and we can start the next paper book in the next session also. So, did you understand the everything that we discussed today? Do you have any doubts? Please raise your hand who understood everything quickly. Please raise your hand who got the things today perfectly. Right. Sir, can you compare and show SO bond length in SO2 and SOCl2? Yes, let's try it. SO2 and SOCl2, ne? SO2 and this is SOCl2. So this is SO2 and this is SOCl2. Right. So this is the way that we can compare the bond length of this one, right? Now, tell me what is the hybridization of this molecule? Sulfur's hybridization? sp2. And the hybridization of this sulfur atom? It is sp3, right? And try to understand, here sulfur and oxygen making a bond. And here also sulfur and oxygen making a bond. Here also sulfur and oxygen making a double bond. Ne? So therefore, we can tell that here we have to compare the SO bond length in this way. sp2, sp3 hybrid orbitals, if you compare compare the distance of the bond length of the hybrid orbitals, which one has the highest length hybrid orbital? sp2 or sp3? Definitely sp3. So that means here sulfur atom is actually using is sp3, its sp3 hybrid orbital in order to form this sulfur oxygen bond. But here sulfur atom is using its sp2 hybrid orbital. So therefore, the hybrid orbital that is using is little bit lengthier than here. Here, little bit lengthier. So therefore, we can say that SO bond length here, it is greater than SO bond length in sp2 molecule here. But in the previous molecule that we discussed, that was NO and NO2. So both of them are actually sp hybridization, ne? NO and NO2 plus, ne? NO and NO2 plus. And here we have NO2 plus. So what is the hybridization of this nitrogen atom? This is also, this is sp2, ne? And this is sp hybridization. A small mistake, students. Actually, this one should be NO and this one NO2 plus. That should be exchanged. Sorry, I thought that both should be same. Right? Look at this one. Look in the previous one, NO2 plus molecule. In NO2 plus molecule, here nitrogen's hybridization is sp. But here nitrogen hybridization is sp2. I forgot about this alone unpaired electron. So that's why I took sp. So here hybridization is sp2. So when the sp2 hybridization is there, we have to consider that the bond hybrid orbital involving in the formation of that bond is lengthier. So therefore, NO bond length is lengthier here than NO2, right? In case if the hybridization is same, you have to compare in that manner that I told you. Can I remember? I told you that the electron distribution is greater. That means spreaded. Here the electron distribution is spreaded everywhere. Then the bond length is greater, right? But here hybridization is different, sp and sp2. So therefore, we have to go for the sp2 hybridization because hybrid orbitals are length. Okay. So therefore, correct that variation in that way. And SO2, SOCl2, which one has the highest bond length then? SOCl. Rafa, can you understand? Now we know this one is okay. This NO plus and NO. There was a small mistake. Actually, I thought that both are same hybridization. Anything else? Please ask if you have any doubts. Because you don't have another time to go through these questions again. Please finish these questions in the classroom. Neither. All right, okay. It seems that you don't have any doubts hereafter anymore. Okay, students, then let's wind up the session for today. NO3 minus have sp2 hybridization, but NO3 minus have single bonds. Since NO3 minus have single bonds, we cannot go for the comparison between NO and NO2 plus. Got it? NO3 minus nitrate anion already have a single bond. If there is a single bond, definitely bond length is greater than the others. NO and NO2. NO and NO2 plus. But in NO molecule, in NO2 plus molecule, there are no single bonds. That's why I put NO3 minus forward, because it is containing not one, there are two single bonds. Understood? So to find bond length, do we have priority order? Yes. The priority order is single bond length, double bond length, and triple bond length. Single bond length is actually greater than double bond length. Double bond length rate is greater than triple bond. Right? So that is the simple order. But we can complicate this one more using the bond order. Bond order. Bond order is actually inversely proportional to the bond length. I taught that one in theories. But my advice is don't use bond order, because bond order is actually completely waste of time. By comparing the single bond, double bond, lengths, you can easily compare that. Okay, right. Then we will have the next session on Monday. You will have the tutorial also. So this month is completely tutorials ending, right? For the 26 batch, for your batch, theory tutorials and the paper class tutorial also. I will prepare that one and you will get the tutorial, right? Then let's meet on the next Monday. Until then, bye bye. Have fun. Good evening for all of you. Study well at home. Don't waste time.